Good morning, everybody. Great heaven. We're going today to get our session of science about forms of energy. We got before what is energy, and we talked about the two main energies we have before. Yeah, the two main types, the way, as you say before, kinetic energy and potential energy. So let's move on to see every form of energy we'll get it after that will be either a type of kinetic energy or a type of potential energy or both together. So let's see guys how the energy transfer from a form to another form. First of all, mechanical energy. And the mechanical energy is associated with motion or position or shape. So if it's a motion, it will be kinetic. If it's position or shape, it will be potential. So mechanical energy equals kinetic energy plus potential energy. Yeah, let's go for mechanical energy. If we want to calculate it, the mechanical energy for an object will be both kinetic energy and potential energy. If we get to the mechanical energy here, for an object at the maximum height of it, it will be equal to potential energy only because the kinetic energy here will be zero. It's depending only on the position of the object. Yeah, but in other situation, yeah, mechanical energy for an object when it reaches the floor down, so the height will be zero, potential energy will be zero, so mechanical energy will be equal to only kinetic energy. Let's get example for that. Yeah, there is a basketballer here playing and throwing the ball to the basket. Let's see, guys, how the change happened for the potential energy. First of all, we cannot say that the potential energy on the floor is zero. Why? Because the basketballer get the ball up, so it's getting a position out of the floor. So here, guys, you will notice that the potential energy here will be what? Will be equal to 12, will be equal to 12 at the point A. And the kinetic energy will be equal to 10. So the mechanical energy will be the addition or the summation of two, yeah, kinetic and potential. It will be 10 joules plus 12, it will be 22 joules. It's not, you know, converted again into the B position. It is the highest optimum point, so the height will be maximum here. We'll see that the potential energy will be maximum to 20 joules, but the kinetic energy will be less into 2. So when the potential energy decrease, the kinetic energy increase, and when the potential energy increase, the kinetic energy decrease, but the total overall will be constant for the mechanical energy. So it will be 2 plus 20, 22, the same with this one, in this position. Yeah. The second type that we have today is nuclear energy. And the nuclear energy, guys, comes from the word nucleus, which is the center of the atom that containing any type of matter. The region in the center will be called the nucleus. And the potential energy, so the nuclear energy here is the potential energy, yeah, saved or stored inside the nucleus of any atom. And when you start to release it in order to make reactions, nuclear reactions, you will get this energy in type of two form. Either fission, if you split down the atom, yeah, of the element into parts or into two new particles, or it will be fusion when you start to fuse two atoms together in order to get a new bigger atom. Yeah, so fission, guys, fission of the nuclear fission occurs when the nucleus splits or breaks down, and that occurs in nuclear power plant. And other one is fusion, and fusion occurs when the nuclei of atoms, and nuclei, it's here plural, yeah, so we have more than one nucleus of atoms fuse or join together. Yeah, and occur constantly in the sun. It cannot be happen directly because it releases a lot or huge amount, enormous amount of energy, guys. So only a tiny portion of energy reaches the earth of this energy of fusion, yeah, as heat or light coming from the sun. Also, guys, we'll get some commons and differences between the fission and fusion here of nuclear reaction. So they are both getting to release energy stored in the nuclei of atoms. But for the fission, yeah, the energy releases when the nucleus is split, but in fusion, the energy releases when two nuclei or more start to join each other together. Yeah. The second type, guys, we get, or third one will be thermal energy next. Yeah, it is the total kinetic or potential energy of the particles in an object. So if the object particles are not moving, it will be potential energy. If the kinetic energy or the motion of particles, it will be the kinetic energy for it. So it might be kinetic or potential. So the higher, guys, the temperature of an object, the more thermal energy the object has. If we get more energy, the temperature will increase. And for example, suppose you heat a bowl of water. So as you heat it, or as you heat more, the particles will move more faster on average of all particles. And the faster the particles moves, yeah, excellent, the greater the kinetic energy and higher temperature increase. Yeah, that's for example when we get the sun heat, the temperature increase. When we get coldness, yeah, the temperature decrease. That means that the particles are moving a little bit, but here it's moving faster. And you can see that in the boat here, and you can see that in the particles here too. So electrical energy, guys, is the next type of energy, and it is the energy of electrical charge. Either it was moving or stored inside. So if it was moving like in electrical lines, yeah, it will be kinetic energy, or if it was stored in batteries, it will be potential energy like that. And we can say that lightning is a form of electrical energy when we want to get some light. Yeah. Sometimes you rely on electrical energy from batteries or electrical line in order to run your devices, home computers, handheld games, or even digital audio players. That's example. For the battery, guys, that's a dry battery, and that's car battery, that's lamps or lighting, and that's to start to get the lines, electrical lines to get energy from. Electromagnetic energy, the next type, and it's a part of electro and magnets. So it's electricity and magnetic field. So both together coming to make that type of waves, guys. And electromagnetic waves are traveling in the space without the medium, not in the air, not in the water, or even in any solid. It can move directly through space. So we can say, guys, that sometimes we get that electromagnetic waves coming from the sun or the stars, like the ultraviolet or infrared in form of heat. And sometimes it's microwaves, yeah, that we can use directly in the food or even for our cell phone to receive messages or even to talk in the cell phone. Yeah, and also, guys, we can see that if you get to the doctor for a broken arm or something like that, we'll get the x-ray that can diagnose your case. And also, guys, we get some types of ultraviolet rays and infrared one, like infrared coming from the sun and ultraviolet too. They are raising temperature sometimes. And get to this one, radio waves coming to the radio microwaves, and also we will get the nuclear coming sometime to give electromagnetic waves, X-ray, and the visible light you can see through it, radar sometimes, and mobile are using the microwaves. Last but not least, guys, chemical energy is the potential energy stored in chemical bonds. So that's a type of potential one. So chemical bonds are what hold the atoms together. So when the atoms are held together, they get all of that energy inside the bonds. Often when these bonds are broken, the stored energy starts to release. And also, examples for that, yeah, when your body cells start to break down the food in order to release energy for your body to use. That's example for that, guys. Energy stored inside the food, you eat it, and after that, the chemical potential in energy growth start to be broken down in order to give you the energy to start to talk or even to sing, even to move. That's kinetic energy and transform to heat energy to warm your body. That's type of food that can contain a lot of energy inside. Thank you for your time, guys. Was with you, Mr. Samir. Wait for my assignments and homework on BSN Realize, and don't forget to solve it. Thank you, guys.